After 2 months of research, that can any other element be used in place of thorium or uranium in the nuclear reaction process, I found that plutonium can also be used, but there are some drawbacks of plutonium because it has a first of all it has a very less half-life as compared to uranium and thorium. Then while processing plutonium, 65% of energy is wasted in absorption, and 95% of time is wasted by the scientists in researching about that. So this is the reaction I am showing that shows how plutonium reacts. First, uranium-238 absorbs a neutron and it gets converted into uranium-239, then which has a 23-minute half-life. Then it is converted to neptunium-239, which has a 2.4-day half-life, and then it again undergoes a beta decay process and converted to plutonium-239, and then when it absorbs a neutron it converts to plutonium-240, which has a poor probability of 65% of fission than absorption, and it also produces 2 fission products and nearly 3 neutrons released in fission. Now I will tell what are the benefits of thorium as compared to plutonium. When thorium-232 absorbs a neutron, it gets converted into thorium-233, which has a 22-minute half-life, and then it converts to protactinium-233, which has a 27-day half-life, and then it gets converted into uranium-233 by a beta decay process, which when absorbs again neutron gets converted to U-233-4, which has an excellent probability of 95% of fission rather than absorption. So you can imagine how uranium-233 can be well used for nuclear reactors from plutonium-232. Now I am going to show how the thorium-based nuclear reactor works. First, the thorium and uranium-233 are dissolved in molten lithium fluoride salt in the reactor. As the fission occurs, heat is released and the free neutrons charge changing from the thorium-232 to uranium-233, as I have discussed earlier the process. The second process that occurs in the reactor is that heat from the reactor is transferred to another loop of molten salt that doesn't contain nuclear materials. Then the third process that is carried out in the reactor is that heat is transferred to the helium gas, which runs the turbines and powers the generator. The fourth process is for a safety measure or an emergency measure in the system gets too hot, a plug is designed to melt at a specific temperature. So the reactor's component to dump tanks. Because the fifth process is because the salt in the reactor is liquid, so waste can be removed while the reactor is working. So before this process is carried out, the solid core reactors must be shut down to remove the waste. Then again, this is the last thing that I have to tell in this review video, that is accelerator driven thorium reactor. So here you can see an accelerator or cyclotron which supplies a beam of high energy proton directed at a specialization target, which enters now to the thorium reactor. Then here the steam is generated and gets transferred to the turbine, and then the turbine gets started and after the driving of the turbine occurs, the energy gets transferred to generation process, and then from here the electricity or energy is generated and transferred to the power generation and then to the households. So that's all for the review 2. But I can tell that this process will be easily feasible by the scientists economically and technically. So now I am carrying out more research on this project, and I want that you all friends can give your opinions or reviews on this video. Thank you.